Hi everyone, we are Team weatherBusters, and for our team project, there are two parts that we are currently working on. The first is to develop an interface for users to plan potential locations for new radars, and we have an engine running in the background to check if there are any interference with neighboring radars. The second part to our project is to gather past flight information, particular flight delays due to weather, and also historical weather information during the same period. After extracting this information, we plan to visualize this in Google Maps and then make use of analytics model to predict future flight delays. As for the technology update, there are a few more additions as shown in the boxes highlighted with a star. We discovered the use of jQuery to more effectively extract and process large chunks of information in our database. This is extremely useful, so we do not have to do a loop through the database, which can really slow down the performance of the application. We also found a weather data crawler application in NPM that makes use of API to extract relevant weather data from National Climatic Data Center web services. This may come in useful if we can find a way to extract specific information we need instead of downloading the large chunk of weather database that's over 2 gigabytes. Finally, we have been using the Google Map API to visualize the information we have. So this is how our software architecture would look like. It consists of the web layer where the HTML files reside, the application layers where we store our JavaScript files, as well as the database layer where the JSON files are residing. Those in orange are what we develop ourselves, and those in blue are what we are looking at to extract the API information from external sources. So as you can see, currently we are hosting on a local host, and our application can be accessed through the network to the client end.
This is our interface for calculating interference. The green markers indicate the locations of existing next-red weather radars in the United States, while the blue markers indicate additional sensors placed there by the users. Adding a new sensor type to the database creates an entry into the JSON file with all the parameters of that sensor. Placing a sensor adds an object into another JSON file with a latitude and longitude attached as well. The ID of the sensor is appended with a counter which increments with every sensor of the same type that is added. The next step would be to write in the logic to check if each sensor interferes with each other and visualize it.
Next, we move on to update what we have so far on the flight delay analytics. Our first step was to retrieve the flight data information from open source and then attempt to plot them on Google Maps. What you see here is the average flight delay due to weather, time-lapse from January 2010 to December 2016. The radius of each circle corresponds to the amount of delay, and so from here, we can easily visualize which are the airports with the most amount of delay and in which months. So with this, we are more or less done with the flight delay information part for this tool. The next step for us is to extract relevant information from the massive database of weather data. So with these pieces of data, we can actually go ahead and analyze them and then come up with a prediction model to predict flight delay based on future weather forecast. Next, we go on to the risk updates. The first and third risk areas are fairly low, so I'll not talk about them. As for the second risk, we assess the risk level to be medium, mainly because currently we only have the temperature, rainfall and snowfall data that we can use for the analysis. So as a mitigation strategy, we would want to be able to accept a lower fidelity model for this project, and if we want to extend this project further, we can look into extending the database. With that, we have come to the end of the second update. If you have any queries, please feel free to reach out to any one of us. Thank you.